Yes, let us start with the named reactions today. First, what you have already done in 11th class also, that is Wood's reaction. Now in Wood's reaction, two molecules of alkyl halide, Rx is alkyl halide, it will react in the presence of sodium, metallic sodium and dry ether to give you an alkane. So this is an alkane. And what is this Rx? It is alkyl halide. So two molecules of alkyl halide in the presence of sodium and dry ether, you will get alkane. So I have given you an example. Chloromethane, two molecules react with sodium to give you ethane. You just have to add the R groups of alkyl halide and you get the corresponding alkane. Then what is fatigue reaction? Fatigue reaction is just same as that of this. The only difference is here we use alkyl halide, here we are using aryl halide. So this is what? This is chlorobenzene which is an aryl halide. Now chlorobenzene, two molecules, they react with sodium in the presence of dry ether to give you diphenyl or biphenyl. That is fatigue reaction. Now we will see Wood's fatigue reaction. That is one molecule of aryl halide and one molecule of alkyl halide, they will react with sodium in the presence of dry ether to give you alkyl as an alkane, that is toluene. You will get methyl benzene formed in this case. That is Wood's fatigue reaction. That is a combination of Wood's reaction and fatigue reaction. Now let's see what is Finkelstein reaction. Finkelstein reaction is to prepare iodoalkanes. Now from where you take either RCl or you may also take RBr and you treat it with sodium iodide in the presence of dry acetone, you will get the corresponding alkyl iodide and NaCl. If it is RBr, you will get NaBr. So you get iodoalkane. Then Schwarz reaction is to prepare fluoroalkanes. Now in this case you take either RCl or RBr and you treat it with silver fluoride and you get fluoroalkane along with AgBr or AgCl. Whichever you are starting with, accordingly the byproduct is decided. Then the next one is Sand-Meyer reaction. Sand-Meyer reaction is to prepare haloarenes. Haloarenes means halogen atom attached to the benzene ring. So here you start with benzene diazonium chloride. This is benzene diazonium chloride. Azota means in Greek nitrogen. So here diazonium chloride because there is two nitrogen atoms. In the presence of Cu2Cl2, you will get chlorobenzene. Now supposing you are going to use Cu2Br2, then you will get bromobenzene. So this is to prepare haloarenes, and specifically you can prepare chlorobenzene or bromobenzene by this method. You can't prepare the same kind of reagent by using, you can't prepare iodobenzene or fluorobenzene from this method. So this is specifically for chlorobenzene and bromobenzene. Then now we saw let us see diazonium chloride. We saw diazonium chloride in the previous reaction. Now how to prepare that diazonium chloride? You start with aniline, that is aminobenzene, treat it with sodium nitrite and HCl at 0 degrees Celsius. This is sodium nitrite, and you will get benzene diazonium chloride. This is called as diazotization. Sandmeyer reaction is diazonium chloride to chlorobenzene or bromobenzene, and formation of diazonium chloride is what is called diazotization. Then what is Kolb's electrolysis? Here you take sodium salt of acid and the aqueous form of sodium salt of acid is electrolyzed, when you will get an alkane, then sodium hydroxide and hydrogen and carbon dioxide. So this reaction can also be called as decarboxylation, that is removal of carbon dioxide. So you can also call it as decarboxylation. Then let us see what is beta elimination. Now beta elimination is you take RX and you treat it with alcoholic KOH and you get the corresponding alkene. So this beta elimination can also be called as dehydrohalogenation. That is, hydrogen halide is removed. That is why it is called dehydrohalogenation. Now here, from the alpha carbon, halogen is removed. From the beta carbon, one hydrogen is removed. So one HBr is removed, and you will get a double bond created between these two carbon, and so you get propene. This can also be asked in the conversion. How will you convert 2-bromopropane to propene? So this is beta elimination. Why it is called beta elimination? Because hydrogen from the beta carbon is removed along with halogen. That is why it is called as beta elimination. Then what is Friedel-Crafts reaction? Here benzene is treated with alkyl halide. This is alkyl halide. In the presence of anhydrous AlCl3 as catalyst, you will get the corresponding alkyl benzene formed, that is methyl benzene, which is toluene. This is called as Friedel-Crafts alkylation, that is alkyl group is attached to benzene ring. Then the next one is Friedel-Crafts acylation. Now here acyl group is attached to benzene ring. Now for that you start with benzene and treat it with acyl chloride. This is called as acyl chloride. More specifically, this is ethanoyl chloride. And what you get? You get acetophenone. This is acetophenone. This is Friedel-Crafts acylation. Now here you can use either this ethanoyl chloride or even you can use anhydride for this acylation process. So that is Friedel-Crafts acylation. Now let us go further, that is Lucas test. What for is Lucas test useful? It is used for distinguishing primary, secondary and tertiary alcohol. Now what is primary, secondary and tertiary alcohol? If the carbon holding OH is attached to only one other carbon, this is primary alcohol. If the carbon holding OH is attached to two other carbon, it is secondary alcohol. And if the carbon holding OH is attached to three other carbon, it is called as tertiary alcohol. Now you treat the three different types of alcohols with concentrated HCl in the presence of anhydrous zinc chloride, and what you will get? Obviously this OH will be replaced by Cl. So you will get, since it is written as test, that means some visible observation is possible in this case. So what is the observation? The observation is turbidity is seen immediately with tertiary alcohol. If the sample of alcohol is tertiary, then you will find turbidity immediately being formed. Turbidity is nothing but some kind of cloudiness within the test tube. And the secondary alcohol will give turbidity, but after some time. Whereas primary alcohol will not give any turbidity during the course of the reaction. But if you heat, then turbidity will appear. But at room temperature, we have to give the observation at room temperature. So tertiary will give immediately, secondary will give after some time, and primary will not give. Then the next one is Kolb's reaction. Now we saw Kolb's electrolysis 1. Now in Kolb's electrolysis, what happened? Sodium salt of acid was electrolyzed to give you an alkane. Now what is this Kolb's reaction? Here phenol is converted to 2-hydroxybenzoic acid. Now phenol, it is treated with aqueous NaOH along with carbon dioxide at 400 Kelvin and 4 to 7 atmosphere. Then you will get 2-hydroxybenzoic acid. Now without this OH group, this is benzoic acid. So this is number 1 carbon and this is number 2 carbon. So 2-hydroxybenzoic acid, which is called as salicylic acid. Then let's go to the next one, that is Riemer-Diemen reaction. Now in this again, phenol is converted to another similar product, but not salicylic acid. You are getting salicylaldehyde. That is 2-hydroxybenzaldehyde. This is 2-hydroxybenzoic acid. This is 2-hydroxybenzaldehyde. This is aldehyde group. Now here what you add? You treat phenol with chloroform. CHCl3 is called as chloroform. And in the presence of aqueous NaOH at 340 Kelvin, you will get salicylaldehyde. That is Riemer-Diemen reaction. Then the next one is Williamson's synthesis. Now here you take alkyl halide, treat it with sodium alkoxide, and you get an ether, that is ROR. Now here, what is the condition that is to be followed while performing this Williamson synthesis? That is, the alkyl halide that you are taking, it has to be primary. It has to be primary halide only. And this RONA that you are taking, it can be any complex alkoxide. Now, why is it so? Why should we do it like this? Why should we take only primary halide? That is because if you take a primary halide and any complex alkoxide, you will get the ether, the desired ether. But in case you take a tertiary halide and a simple alkoxide, then what will happen? The reaction will not give you ether. Instead, it will give you an alkene. We will get an alkene. If we use tertiary halide and a simple alkoxide, then we will not get ether, but then instead we will get an alkene. So here the C2H5ONA will act as a base, that is to take out a proton. So it will take out a proton from here. With the result, what will happen? A double bond will be created between these two and you will get the corresponding alkene. You will not get ether. Then what is Rosenmund reduction? Now here alkanoyl chloride is treated with hydrogen in the presence of palladium and barium sulfate. Palladium rod smeared with barium sulfate precipitate, when you will get aldehyde. So here, since addition of hydrogen is there, that means it is a reduction process. Now what is happening, you see, this Cl goes off with this hydrogen as HCl, and when you remove this Cl, you are going to replace it with a hydrogen. So you will get aldehyde group. So ethanoyl chloride, how will you convert it to ethanol? That is by Rosenmund reduction. You treat it with hydrogen in the presence of palladium and barium sulfate, you get the corresponding aldehyde. Same way you take benzoyl chloride and treat it with hydrogen, you will get benzaldehyde. Now what is the role of this BaSO4? BaSO4 acts as a catalytic poison. It acts as a catalytic poison. Then another important reaction is Hoffmann bromamide reaction. Now here you take an amide and treat it with sodium hydroxide and bromine, and you will get an amine. So now here what is the significance? Whichever amide you are starting with and the amine you are getting, amine will have one carbon less than that of amide. So say for example CH3CONH2, then look at the amine that is formed, it is CH3NH2. That means it looks as if the CH3 is directly attached to NH2 and this CO group has disappeared. Okay, so this is used in the descent of series. Supposing you want to reduce the carbon during the course of a reaction, you can subject it to this Hoffmann bromamide so that you can reduce the number of carbon atom. So that is Hoffmann bromamide reaction. This is a very, very important reaction. They can ask you even in conversion, how will you convert ethanamide to methylamine? Ethanamide to methanamine. This is methanamine, this is ethanamide. So this is by Hoffmann bromamide reaction. This can be asked even in conversion. Okay, now let's go further. That is Wolff-Kishner reduction. Now in this Wolff-Kishner reduction, you start with aldehyde or ketone, treat it with hydrazine. What is this NH2? It is called hydrazine. In the presence of KOH and glycol, you will get the corresponding alkane with same number of carbon atoms as that of aldehyde or ketone. So here look, when you say again reduction means addition of hydrogen. So what is happening here? RCHO is becoming RCH3 or RCOR is becoming RCH2R. That means basically what is happening, this C double bond O is getting converted to CH2. This is the basic change that is taking place. C double bond O has become CH2. This hydrogen is already there, this is already there. Same way C double bond O has become CH2. This is what you have to understand. So here also they can ask you like this, questions like how will you convert ethanol to ethane? So it can be done by Wolff-Kishner reduction. The same conversion is also possible under a different set of conditions, that is called as Clemmensen reduction, where you again start with aldehyde or ketone, but instead of this hydrazine, KOH and glycol, you're going to add zinc amalgam and concentrated HCl, when you will get the corresponding alkane. It is just the same. So zinc amalgam and concentrated HCl is used, and this will provide hydrogen, and that hydrogen is used for the reduction purpose. So here ethanol to ethane, propanone to propane, benzaldehyde to toluene. So all these things they can be asked even in conversion. So if they are asking you any of these, then you can easily follow either Clemmensen reduction or Wolff-Kishner reduction to do the conversion. Then the next one is Cannizzaro reaction. Cannizzaro reaction is an auto-oxidation reduction reaction. That is, you take two molecules of aldehyde. What kind of aldehyde? Aldehydes which do not have alpha hydrogen. Now here, what is alpha hydrogen? Alpha carbon is the carbon holding the functional group, and hydrogen attached to that alpha carbon is called as alpha hydrogen. So here you are having carbon, but there is no alpha carbon at all. So if there is no alpha carbon, obviously there is no alpha hydrogen also. So such examples, those which do not have alpha hydrogen, you can give methanol as an example, then benzaldehyde also as an example, which doesn't have alpha hydrogen. See, look, you have alpha carbon, but there is no hydrogen attached to this carbon. So you will consider under this category. So here one molecule of aldehyde will get oxidized to acid and the other molecule will get reduced to alcohol. So it is called as auto-oxidation reduction reaction. Same way, if you take benzaldehyde, one molecule will get oxidized to give you the corresponding benzoic acid salt, because you are using concentrated NaOH here. So you will get the salt of acid, and one molecule will get reduced to C6H5CH2OH. What is this? This is benzyl alcohol. And what is this? This is sodium benzoate. This is methanol, and this is sodium methanoate. Right? Okay. Now the next one is I've shown you what is alpha carbon and alpha hydrogen. The carbon holding the functional group is called as alpha carbon, and the hydrogen attached to such an alpha carbon is called as alpha hydrogen. Then the next one is carbylamine reaction. Now here what happens? Amine gets converted to isocyanide, and this is used as a test for primary amines. This is used as a test for 1-degree amine. If the sample of amine is primary, then you will get a foul smell while performing this reaction. What do you add? You add chloroform and alcoholic KOH, that is KOH dissolved in alcohol, and you get alkyl isocyanide, which has a very bad smell, very foul smell. So this is called as carbylamine reaction. Say for example here, like if you are asked to distinguish between, say, ethylamine and diethylamine, then you can perform this test. C2H5NH2 being a primary amine, this will give a foul smell when treated with chloroform and alcoholic KOH, whereas diethylamine will not show the reaction. So this can be used for distinguishing test. Then the last one is aldol condensation. Now what is the difference between Cannizzaro reaction and aldol condensation? In Cannizzaro, aldehydes which do not have alpha hydrogen is used and concentrated NaOH is needed. In this presence only the reaction takes place. Whereas in aldol condensation, aldehydes which have alpha hydrogen should be used, and the reaction takes place in the presence of dilute OH-. So here two molecules of ethanol, just like the Cannizzaro reaction, here also you will take two molecules of aldehyde, but here the condition is they should have alpha hydrogen. If not both the aldehydes, at least one should have alpha hydrogen. So I have taken a aldehydes of the same kind, just for example. So when you take two molecules of aldehyde and treat it with dilute alkali, then what you will get? You will get an addition product, and that addition product is called as aldol. Now why it is called aldol? Because it has aldehyde group as well as alcohol group in it. That is why it is called as an aldol. Now how that is done? Here expand this structure of CH3CHO, the CH3 C double bond O hydrogen, and in the other molecule take out one of the alpha hydrogen, put it separately like this. Now when these two are added in the presence of dilute alkali, the alpha hydrogen of the second molecule will add on to the carbonyl oxygen, making it OH, and this CH2 group will get attached to the carbon of the aldehyde group, and so you will get an addition product like this, that is CH3 CH. Now this hydrogen is attached to oxygen, so it becomes OH, and then this C will attach this CH2CHO. So this is called as aldol, which on heating will lose a molecule of water. How that water molecule is removed? OH of this carbon and one hydrogen from the adjacent carbon. It is removed as water. So what is left behind is CH. Since two groups are removed, then there will be a double bond formed here. So you will get CH3 CH double bond CH CH. Now this carbon is called as alpha carbon because it is holding the functional group, and the adjacent carbon to alpha is beta. So between alpha and beta you have a double bond, and hence it is called as an unsaturated aldehyde.